Wonderful. So I don't know everyone on the call today if we want to just give a little introduction about ourselves. I'll start real quick. Like I said, my name is Michaela. I'm a member performance specialist here at WiscNet. And then I'm joined by a few of my other colleagues. Do you want to introduce yourselves?
Good morning, everyone. My name is Ivar Margevich, and I'm a member fulfillment specialist for WiscNet as well. It was nice to meet a lot of you face to face at our conference, and now we are back to our virtual sessions. Welcome.
Hi, I'm Eric Hammonds. I'm WiscNet's newest platform engineer.
I'm Josh Gordon, platform engineer here at WiscNet.
Few things that we're going to be kind of going over about our Connect+1 service today is just kind of an overview of the service, a little bit about the engineering, and then the deployment process.
All right, we'll start with service overview, and in general, I'll cover some of the points about what the service is. And again, Connect+1 is a WiscNet service that we provide. It's getting its popularity right now. What does it do? It allows WiscNet members to utilize multiple connections from their site to the WiscNet backbone. The reasons for that could be, there's a variety of that, as you can see on the slide as well, to increase reliability, to add capacity, or to connect a separate campus directly to our backbone. Who is it for? It is really for all of our members, for those who have network access. If you have network access, you do qualify for this Connect+1 service. Features. It is really easy to implement for us, and it does cost not much, I should say. It is at a low cost, and we do assist you. Well, we recommend you certain circuit providers. Typically, we are aware if there are any cans in your area. We do work with bigger organizations as well, and we do encourage you to go out there and talk to your local telcos as well. Next slide, please. Pricing, as I've mentioned already, it is a very, very affordable price for this service. We do charge $1,320 as an annual fee, and there is a one-time installation fee. If you choose that capacity to be up to 1 gig, it is $500. All the way up to 10, we do charge a $2,000 installation fee. And depending on what you would like to do, if there are any additional routers or any other technical things, we look at that from a technical perspective, and Josh will cover that later. If you're interested in seeing quotes or scheduling a call with us, or a meeting with us, where we will discuss your particular situation, the email is on the screen, membersuccess@wiscnet.net. I know there are always questions about E-rate. Is it eligible for E-rate? And remote locations may be eligible. And again, we encourage you to give us a call or to schedule a meeting, and we'll cover that on individual basis. But we can tell you right away that it does not cover redundant connections. Yes, redundant connections or increased capacity. But again, give us a call or email us, and we'll work with you on a case-to-case basis. And that's kind of a general overview of our service. And I'll let engineers to chip in and actually describe it on a more technical level.
Yeah, thank you, Ivar. So I wanted to include this slide before beginning. I think it's important to note that we don't have just one cookie cutter implementation for Connect+1. There are closer to 8 different types of implementations. And if you have a use case that we can reasonably model with standard protocols, we're likely to consider it. As you see the following slides, please keep in mind we're just covering the most common implementations, and please feel free to ask questions if you have alternative designs you'd like to hear about. And also I'm trying to strike a balance between getting a little technical but not being boring. So ask questions if there's something you want to hear more about. So this is a photo of our backbone weather map. This is from today. It's very convenient. There's like zero traffic now that school's out. No, I'm just kidding. The weather map's normally pretty green. So these are different locations that you can connect to WiscNet for Connect Plus One. And I wanted to call out what if your site isn't shown here. So a lot of community area fiber networks are actually extend quite a bit out from the cities they're located in. Like Sync, I think, reaches out pretty far away from Eau Claire. And then also different telcos and regional providers, whether it's the new Teach Network or somebody else. We also connect to a lot of them. So if your site's not on here, don't panic. There's probably options for you. So getting into the technical bits a little bit. So if WiscNet deploys a router at your location to manage Connect Plus One for you, it will be a Cisco ASR 920. As photographed here, has 4 10 gigabit per second ports, and it can do line rate throughput on all of these ports. So you can get a full, hypothetically 20 gigabits per second if you're doing something like a lag handoff. It has redundant power supplies, which is nice. And if you choose to not have a WiscNet managed router at your location, we can talk about that. We typically call that site managed. And then on the other side of the connection, so the backbone devices you're connecting to, I just thought we'd share in case you're curious. It's either a Juniper MX or Juniper QFX, and those are kind of 2 different tiers of hardware. One of the big differences between the 2 is that our MXs hold a full internet routing table, and the QFXs do not. So all 850, 900,000 routes on the internet, the MXs hold. So on the routing side, if you currently have network access but don't have a redundant connection, it's likely that your public IP addresses are either statically routed to you or they're in OSPF or IGP. If you go to Connect Plus One, where you're handling more than one circuit at one location, we will convert you to Border Gateway Protocol, BGP. The routing happens on the ASR 920 at your location. So your public IP, like your gateway on WiscNet's network, actually lives at your location. There's a lot of advantages to this, and it allows us to fail over circuits really efficiently. In that situation, we assign a private BGP autonomous system number to the ASR 920, and the ASR 920 actually gets transit from WiscNet. And each circuit gets its own point-to-point IP address assignment. And then for fast failover, we configure bidirectional forwarding detection, BFD, on each of the circuits, which sends hello packets every half second. And if there are 3 misses, it will shut down that circuit. The advantage to turning on BFD is that if there's a layer 2 device in between the ASR 920 and WiscNet's backbone, it doesn't matter if there's an issue in the middle that doesn't take the actual physical interface down, we'll still detect it really quickly. I've tested with a lot of members, and typically if you're running like paying out to some internet destination, it's about one ICMP packet lost, about 1.5 seconds. And then if you have multiple ASR 920s that WiscNet manages at your site for hardware redundancy, we can run virtual router redundancy protocol, VRP, on your gateway so that you can lose an ASR 920. So for monitoring the service, we have quite a few different monitoring servers that we use. So for monitoring jitter, latency, and loss testing, we actually use Cisco service, Cisco IP SLA, and it monitors each circuit individually. So if you have two circuits to WiscNet with Connect Plus One, they're each monitored independently, and they're monitored from Eau Claire and Madison, where we have Cisco virtualized routers doing the IPSLA service. We also SNMP poll to do things like graph errors, discards, laser light level, bandwidth, stuff like that. That's from software called Observium. Our 24/7 NOC also monitors all of our devices via SNMP. And then we have revision control via Rancid, which is open source software. And then we also gather syslogs from all of these devices. And you can view a lot of this information yourself by going to graphs.wisnet.net and looking up your institution name or circuit ID. It is a little picky about matching, so you can just do like 3 or 4 characters of your institution name, and you should find your circuit graph. So for load balancing, when you do have 2 circuits to one location, outbound is relatively straightforward. On the Cisco AS920s we deploy, we have maximum paths 2 configured under BGP. So the router will install 2 default routes in the RIB and FIB, or in the FIB, I should say, and it will perform equal cost multipath load balancing. So outbound traffic is really well load balanced. Inbound, because the AS920 is running BGP and gets transit from our backbone, essentially, packets going to your site follow just our interior gateway protocol and our backbone routing scheme. So if there is not great inbound load balancing, we do have some BGP action communities that we can try to influence the inbound traffic a little bit. The absolute best way to get a bit of balanced inbound traffic is to connect to 2 geographically diverse WisNet routers. And at the bottom of the screen here is a members graph that has 2 circuits, red and green, and these graphs are actually stacked, so you can kind of see a bit of load balancing happening for this member. I have some graphs prepared, and before getting into a lot of Connect Plus One increased bandwidth and redundancy diagrams, I just wanted to share high level how a member may connect today when the member does not have Connect Plus One. So these are 2 graphs, one showing where WisNet does have a managed AS920 at the member's location and one without, and just generally how the routing looks and how they're connected. So it's relatively straightforward. AS920 has a point-to-point to the backbone and has an interface handing off to the member. If there is no AS920, the member is routed at the WisNet backbone router. So this is the first example of Connect Plus One to one location, one member location. This example kind of shows what it would look like if you had 2 circuits to one backbone router on WisNet's network. You might ask, why would I do that? You know, there's no device redundancy here. Where this might make sense is where you have community fiber between your location and the WisNet backbone that's redundant, or if you only have one option available to you for transport. The positive points about this type of connection is that load balancing is a lot easier. ECMP, equal cost multipath, can happen on both the backbone router and the CPE. So you get much closer to 50-50% load balancing. And we still have that fast failover of a second and a half or less if either of the circuits go down. And this type of service can also be configured when there is no AS920. This is probably the most common example, the diagram on the left, where there's one managed WisNet AS920 connecting to 2 WisNet backbone routers with one member handoff. In this situation, either circuit could go down, or either of those 2 clouds, the WisNet backbone router could go down, and member services wouldn't be impacted. If the ASR 920 failed, there would be service impact. It's maybe worth mentioning WiscNet does stock ASR 920s. So it's not, waiting for a Cisco RMA to get you back up and running. But this is very common. We have quite a few of these deployed. And then again, it's worth mentioning we can deploy this without an ASR 920. The member would have to, without an ASR 920, either use like link monitoring on a firewall or speak BGP with WiscNet to fail over the same public IPs between the two circuits, but it is possible. And now we're getting into full device redundancy from WiscNet's perspective. Just an expansion of the previous diagram, there's now an additional ASR 920. In this situation, WiscNet configures a point-to-point between all of the WiscNet hardware involved, and the ASR 920s actually have their own IGP. We'll configure OSPF area 0 between them in addition to BGP so that they can fail over to each other and use either of those two circuits to WiscNet's backbone for the member traffic. And then the handoff to the member is really up to you. It can either be two unique handoffs if you don't need to fail over your public IP addresses, and you can do something like link monitoring on a firewall. Or we can run VRP on the ASR 920 handoffs. So that way you have a virtual gateway that can float between the two ASR 920s so that if an ASR 920 fails, you won't have service interruption. And then just highlighting again, I couldn't fit this diagram on the last slide. There just wasn't enough space that if you do not have a WiscNet managed ASR 920, that you can speak BGP with WiscNet and achieve the same redundancy between two hub devices if you have two edge devices. So if you have two routers, you can talk BGP to us and fail over, or you can also just have two separate IP handoffs and use link monitoring to fail over between the two. And then I wanted to mention that if you, whether it's cost or technical limitations, do not have circuits that are of equal size, where load balancing might not make sense. We have a lot of BGP action communities, like I briefly touched on earlier, and we can do traffic engineering to influence traffic over your two circuits. So in this example, there's a WiscNet managed ASR 920 at the member location, and a 1 gig circuit and a 10 gig circuit to the WiscNet backbone to two different devices. And on the ASR 920, it's relatively easy for us to configure. In fact, the code you see here is the only configuration change needed to tell our backbone routers to depref the 1 gig circuit and to pref the 10 gig circuit. And then setting the local preference on the ASR 920 to 80 here achieves the same thing. So in this example, all the traffic would be going over the 10 gigabit per second link. WiscNet would still be monitoring both the 1 gig and 10 gig circuit. And if the 10 gig circuit had a service interruption, the 1 gig circuit would take over. And I forgot to mention on a previous slide before we switch over to the deployment process, that if you have two sites, geographically diverse locations, these solutions are also possible at each of those locations. Just if you need public IP addresses to fail over between two geographically diverse locations, they will have to be connected in some fashion. But otherwise, all of these diagrams could apply to diverse locations. Working +1. Thanks.
Thanks. Very nice technical overview, Josh. So our deployment process, we have done plenty of these, so we have that pretty well lined up. The first thing we're going to do is look for available ports on our backbone routers that we're thinking of sending you to. So once we verify you have transport to a given site, we reserve the ports on the backbone routers, and then we make an entry in NetSuite, which we also use as a ticketing system, but we track circuits through there. So that is our source of truth for that. And then we use another tool called NetBox, which is an IPAM system, IP address management, where we can assign you the new private ASN we'll be using. We assign you IP addresses, that being your point-to-point addresses plus your LAN pool. And then we can model the devices themselves in NetBox and assign IP addresses to interfaces. So as we get this set up, let's say if you already have the transport set up and we have access to your existing CPE router, we will test the layer 1, 2, and 3 connectivity to make sure that that point-to-point link is up. And before we turn on our routing, it won't necessarily do anything but just communicate that the link itself is up. So this is an actual screenshot of our NetBox. Through some automation efforts of one of our other engineers, Chris Wopat, we actually can use the IPAM system to generate configuration for the devices using what are called Jinja 2 templates. So we can actually click one of those 2 buttons in the GUI and it will give us a plain text full configuration for the CPE device. And then we can also generate the configuration for the backbone hub device, which is in a copy-pastable format that on the time of the turn up, we can copy it out of there and apply it to the backbone device. So as for the turn up process on the day of, we would first schedule a maintenance window, and this includes even if we're just adding an additional connection, because the cutover to BGP, as suggested by Josh earlier, is a very brief interruption in traffic as that cuts over to BGP. So at the beginning of the maintenance window, we will enable BGP and BFD on your CPE device or devices. As discussed previously, BGP is how our CPE device communicates routes to your network, to WiscNet's backbone, and then BFD monitors the links for failure. We would then confirm that we have a default route and confirm that your traffic is routing back to our backbone. And once that's ready, we disable OSPF, which for single-homed CPE devices is how the ASR communicates what it's directly connected to. But once we have BGP up, we do not need OSPF any longer, so we disable that. Once we confirm that everything is up, we want to test failover, and that can be as simple as removing the jumper on one of the WAN connections going towards the backbone. And as Josh said previously, that is often not even noticed when you disable the primary connection and it fails over to the secondary circuit. That's often not even noticed. You may lose one ping. So testing failure of both circuits is very important to be sure that everything's configured correctly and it's working as intended. As for our monitoring, we also have a script set up that will automatically generate PTR records, which if you've ever done a trace route from your network over the internet, you'll see there are multiple entries with the reverse record for whatever interface.ip4 or ip6.wiscnet.net. So you can at a glance determine when you're actually hitting WiscNet devices during your trace route. We have automatic discovery. All we need to do is enter the hostname and SNMP community in our Observium monitoring tool, and the device will be automatically populated into that service. IPSLA is similar, and Rancid auto-discovers as well. And then graphs.wiscnet.net is populated also by our circuit records, which the source of truth, as we said previously, comes from NetSuite. So there we go. And as for automation that I mentioned previously, when we reconfigure your CPE device, we log into the server that our IPAM system is hosted on, and we can run one line of a one-line command, and this will check the current config on the existing device that's in the field. You do require connectivity to the device, of course, to be able to run this. So you run this command on the IPAM server, and it detects what the device has configured currently, what the staged config is according to our IPAM system. It generates a diff that we can view. You can see on this one, it's adding an interface called BDI 104 and enabling it with no shut. And then it asks you if you'd like to apply changes. And we can run this just to check as well if we're looking to make sure the existing config is congruent with what we have ideally set up in our IPAM system. So that makes the whole deployment process very smooth. This can usually be done within 10 minutes. We like to schedule an hour window in case we have any troubleshooting that needs to be done. But yeah, this speeds up the deployment process greatly, not having to manually enter config. That about covers the deployment process.
Wonderful. Thank you, Eric and Josh. So our next, before we hop into if anyone has any questions or anything, our next meeting is going to be on Thursday, August 17th. Same time slot, 10 to 11. So keep an eye out for communications regarding that. And then does anyone have any questions, feel free to unmute. We also have a few of our billing team here if you have any questions regarding that either, but yeah, feel free to unmute. It doesn't look like any questions got dropped into the chat, but.
Hi, I do have a question. With moving over to BGP for the routing and getting this set up, would there be a change of our public address space, or would it be the same IPv4 network that we have currently?
So this is Josh. Nope, you can keep your IP addresses. So the only situation where you would not be able to keep your IP addresses is if you also had a second ISP to fail over your public IPs. But yeah, with one, two, or more connections to WiscNet, you can keep your existing IPs during the transition.
Okay.
Looks like we have a question in the chat from Todd. What is the lead time to set this setup?
I think the longest piece will be getting a redundant circuit. So if whether it's from a local community area network like the city or the county or a nonprofit organization, or a telco like Charter or BadgerNet, what's now Teach, getting the new circuit and getting the contract signed and getting the new circuit implemented is probably the longest piece. Staging the configuration in NetBox, like Eric described, and then pushing the configuration with our automated scripts is probably 2 hours of work. So a lot of it's just waiting for the new circuit, making sure the new circuit's working, and then scheduling a maintenance window.
I have a question. This is Mike Daly from CISA 9. This is fiscal, so will the cost for the additional circuit incur additional costs in terms of school members beyond an initial port charge?
Hi, Mike. It's Aneta here from
Hi, Aneta.
WiscNet. So the only thing that we ask is that members have one main connections with us, the network access, and then this will be their secondary connection. The secondary connection, or the Connect Plus One, as we call it, is the $13.20 annual fee. And then the one-time fees that Ivers mentioned are, if it's a second 1 gig connection, it's $500 one-time fee, and $2,000 for 10 gig one-time fee. If a second router is needed, that's $4,500. But as Josh said, that's not always the case. So we would look what the cases are based on everyone's needs.
Yeah, thank you.
Looks like we have a few more in the chat. Tony asked, if we have WiscNet router failure, how long does it take to get a replacement, and what's the procedure?
Yeah, that's a great question. So I briefly touched that we do spare them in our office. So on top of that, the replacement process for a failed router would be grabbing a router from our storage, putting it in our lab, and doing one of two things: either taking the auto-generated config from NetBox and pushing it to the AS920, or taking a revision backup from Rancid, which we also have, and pushing it to the AS920. For newer Connect Plus One configurations, that should almost always be NetBox configuration push. So process of us grabbing an AS920 and getting a backup config or a newly generated config on it, they take a while to boot, but that's probably sub-hour. Getting it to you is much trickier because of how do we get it to you? So shipping is what we've been doing now, which obviously takes a lot of time. Sometimes members have driven to our office to pick one up. Sometimes we've made exceptions where it makes sense to try to drive one out, but typically we ship it. A faster solution is to temporarily disable Connect Plus One and move your public IP address to the WiscNet hub router. Again, that will have to be a little bit case by case. Your edge device would have to be able to land whatever the transport method is. But hypothetically, that's also an option that gets you back up, closer to 30 minutes instead of waiting for a device to ship. We do have more and more members choosing to implement 2 AS920s for this reason. Obviously, there's a one-time cost associated with purchasing the AS920.
I think it's worth noting too that we have seen, I think, maybe 1 or 2 ASR920s fail in the course of using them. So it seems to be a very reliable platform.
If we do ship it, how long do we typically see that it does take to get to them? Do you guys?
We've seen next day typically.
Okay.
Someone asked about a pickup city. So we have worked with a few communities where, as a collective, a community decided that having a local ASR 920 backup would be strategic. And if that's something you're interested in, let us know. Obviously, it's just the cost of the ASR 920, but we can have spare ASR 920s deployed as long as we have the ability to plug them into our network so that they're monitored and we don't lose track of them. And, you know, they get iOS updates and stuff like that. But I think there's 2 or 3 of those out in the wild today. I saw a few other questions come in. Any vendors that we can't use? I'm going to say no. We haven't run into a technical reason to not work with any vendor. Today, we have quite a list from Ensight to Astria to MWFN to Spectrum to AT&T to Teach Network to quite a few community networks from Sync to VCAN to Muffin to different county connections. So far, we haven't had an issue working with anybody. And we want to be very open to working with everybody. So
I have a question regarding E-rate. That has always been the thing that's made this seem a little impractical to me over the years. If we were to try filing for E-rate, obviously the WiscNet transport would be E-rateable. Presumably the Connect Plus One service would be E-rateable as category 1, but we would still have to get the transport. We currently use BadgerNet, going to be Teach Network, coming up sometime this summer, maybe. And we have different fiber from different providers that terminates right in our server room. We have Frontier Fiber that we used to connect to the old BadgerNet and connect to WiscNet through Milwaukee. We have Charter Fiber that we're currently using for BadgerNet that runs to Madison. It almost seems like we are set up ideally with 2 different fiber paths running in different directions on different providers. But in terms of trying to file for E-rate, you know, assuming I could make the justification, we need these 2 circuits for capacity, not just redundancy. What would that look like in terms of an E-rate filing, if you're able to comment on that at all?
Hi, Corey. It's Aneta from WiscNet. I'm not sure about the filing of the circuits. I don't know if Mike here has done it on the member side. Mostly we've seen people do E-rate for remote sites when it's like a second location. And I can like probably connect you with some of the members that done that. But from us, if we know that you're having on another location, or we can try to push our 1320 through E-rate. A lot of people don't go that route to try to E-rate that fee because it's so low already as cost, and the justifications are hard and going through audits and things. But again, we can try to work with you individual basis.
Because I think this is something that has been on the back of my mind for years. We used to have a redundant connection to WiscNet at one point that we were kind of justifying based on capacity in this, and it was unequal load balancing, you know, on different circuit types, and it was kind of a mess before there was a more standardized setup. And I really do miss that redundancy. It's something I would love to move back to in the future if we could. So this is certainly interesting to me.
Yeah, we have a lot, probably over 100 members who are using that service, and
Oh, wow.
very, very little of them are E-rating it, mostly the ones who are having like a remote location. But again, like 5% probably of them, I would say.
Looks like I've messaged in, does there need to be a meeting with the circuit provider and ourselves to coordinate the setup and verify service locations to the WiscNet POP?
I think that's a good idea. We have had members come to us after ordering a circuit because we have a few well-defined locations where telcos already have a presence in the same room that WiscNet does, like 1210 West Dayton, for instance, here in Madison, but several other locations as well. But I think it's a good idea to get us on at least one or two calls together, just to figure out what's most optimal, right? Like if, you know, depending on what region of the state you're in, there may or may not be optimal WiscNet location that might save you money from distance the telco circuit has to travel, or just to route packets more efficiently to you. And I think we have a list of that. I think that several of the telcos are aware of. But yeah, I think having a conversation with us is a good idea.
Okay, that was all the questions in the chat. Does anyone have any other questions? Again, feel free to unmute.
I have a tangent that I think a lot of people on this call would be interested in. WiscNet Engineering got word from AT&T that we should have a test teach network circuit, hopefully within the next week or so, to actually do a lot of testing on the new teach network, hopefully before any member migrations happen, so that we get to eat our own dog food a little bit and do a lot of testing.
That does bring up another question. I don't want to veer too far off of the Connect Plus One topic here, but do you have any migrations for members to the new Teach Network scheduled on the books yet? We haven't even heard anything about a site survey yet at this point.
I'm not 100% certain, but I believe the answer is no.
Okay, well, it's not just us then.
But we do have billing figured out with AT&T, so billing will switch to WiscNet starting July 1st, no matter where that transition.
So I don't need to worry about our internet connection just going dark in a couple weeks. Okay.
No. Yeah.
The only information that I got was actually probably maybe like last month, a school district called and kind of asked that same thing of timeline. Are we just going to lose service? And the information that I got were that they were starting to install the new circuits, but they weren't cutting anything over yet. They want to do them in batches and like waves, and that transitions very roughly were planned to start mid-June, but could, be over the next couple months. So being mid-June now, they are roughly planning to kind of start transitions, but again, that was all what I heard a couple weeks ago. But definitely we were confirmed that the contract that we have is until I think January of 2024 or something like that. So you're not going to lose any service. You'll have your service up until they do all of their transition.
Okay, thanks.
I want to keep this chat open a little bit for Josh and Todd to kind of go back and forth. But in the meantime, does anyone else have anything for any of us? Okay. Well, then if not, again, I will send this recording. You'll probably get it next week to everyone who registered. And then if there are other people in that you work with that you want to share it with, definitely feel free and reach out to the email on the screen here if you have any follow-up questions or anything like that, and we can get you in touch with whoever you need. But otherwise, yeah, we'll give you back 12 minutes of your time. And have a great rest of the week and weekend. And thank you guys all for joining us.
Bye.
Thanks, everyone.
Thank you. Bye-bye.
Everyone for
Thanks,
joining.
everyone.
Bye.